Hello, good afternoon, guys. So today we are going to talk about weather service. Weather service in aviation is a joint effort by multiple organizations like the National Weather Service, Federal Aviation Administration, and the Department of Defense. Although weather forecasts are not 100% accurate, meteorologists have the ability to predict weather patterns, trends, and characteristics with increasing precision through careful scientific analysis and computer modeling. Various weather services work together to form up to date weather information that enable pilots to make informed decisions before and during a flight. So, observations. Both weather forecasts, advisories, and alerts are focused on the data gathered from surface and upper altitude observations. Weather measurements are of four types. These are surface, upper air, radar, and satellite. So, surface aviation weather observations, or METARs, are a list of current weather elements at individual ground stations around the US. This network consists of government and privately funded facilities that provide constant, up to date information on the weather. Automated weather observing systems, automated surface weathering systems, and Air Route Traffic Control Center are facilities that we call automated weather sources, and they play an important role for surface observations. So, surface measurements provide local weather conditions and other related information for a 5-mile radius from a particular airport. So, the included information in the METARs are the following: report type, station identifier, date and time, modifier, wind, visibility, visual range of runway, weather conditions, sky condition, temperature, altimeter, and remarks. So we will dive further into this metars in the later part of the topic. So one of the automated sources is the Air Route Traffic Control Center, or ARTCC. So the ARTCC maintains separation in the en route flights conducted under instrument flight rules. Center radars, or air route surveillance radar, show weather as LASH region for light precipitation and HS for moderate precipitation. Upper air observations. So upper air weather observations are more difficult than surface observations. There are two approaches from which we can track upper air weather phenomena, and that is radio sonde observations and pilot weather reports, or PREPs. So the radio sonde is a cubic instrumentation suspended below a weather balloon. So what happens is, as the balloon or the instrument goes up in the sky, it collects various pieces of data as well as wind speed and direction, such as air temperature and pressure. Then once the information is processed, it is transmitted through a 300 milliwatt radio transmitter to the ground stations. Then once the balloon reaches a certain point where it cannot go any further, it will pop, and the probe will come back to the ground, but it will be slowed down via a parachute. As for returning the probes, there are written return instructions on each side of the probe. So PREPs or pilot reports are observations made and filed by pilots during flights. So for radar observations, we have the WSR-88B NEXRAD radar, or otherwise known as the Doppler radar. It offers in-depth observations. So the Doppler radar has two modes of operation: clear air mode and precipitation mode. The radar is in its most responsive operating mode when it is in clear air mode, since a slow antenna rotation enables the radar to analyze the atmosphere for longer. In this mode, images are updated at about every 10 minutes. Meanwhile, precipitation mode have stronger return signals, and its image update rate is about 4 to 6 minutes, so it's faster than clear air mode. So this is the example of the Doppler radar and its intensity ranges. So the Terminal Doppler Weather Radar, or TDWR, is built near major airports and helps the ATC with extreme weather alerts and warnings. The terminal radar ensures that pilots are aware of wind shear, rafts, and heavy flooding, all of which are unsafe for aircraft to arrive and depart. For the third type of radar, which is the FAA Airport Surveillance Radar, it is widely used in the detection of precipitation. This radar is mainly used to track aircraft, but it also monitors the direction and severity of precipitation used to direct aircraft traffic in an airport area during the extreme weather. So the fourth type of radar is the airborne radars. They are aircraft-driven equipment for detecting weather disturbances, which means they are loaded onto aircrafts. Typically, the radar antenna is located on the nose of the aircraft. So for satellite, with recent improvements in the satellite technology, individuals can receive almost real-time weather information. Satellite weather. Weather services are expanded and improved by private sector and satellite technologies. Pilots are now able to receive weather information anywhere in the world without the constraints from geographical landscapes. And pilots are now able to receive weather updates in which they no longer need to request detailed details from weather briefing staff. Pilots can easily receive a weather update by looking at the computer screen due to continuous satellite broadcasts. In other words, with the help of satellite technology, it has become more convenient in accessing weather information. Satellite weather products. Relevant meteorological information, or SIGMET. SIGMETs are weather advisories provided for safety of all aircrafts. SIGMETs cover at least 3,000 square miles of area data on severe weather conditions. As you can see here, this is what a satellite SIGMET looks like. As for the AirMet, or the Airman's meteorological information, it covers conditions of lesser severity than SIGMETs. And this is what it looks like. Service outlets. Service outlets are government or private facilities offering weather services to the aviation industry. These include the FAA, NOAA, or the National Oceanic and Atmospheric Administration, and the NWS. The Automated Flight Service Station, or the AFSS, is the main source of weather information for pre-flight operations. So it has 24/7 pre-flight weather briefing service and can also provide in-flight weather advisory services. The Transcribed Information Briefing Service, or TIBS, provides continuous meteorological and aeronautical information records over the telephone. They are also available 24/7 via a touchtone phone. Direct User Access Terminal Service, or DUATS. DUATS allows pilots with current medical certificate to access weather information and to file a schedule of flights via a computer. There are two ways to access DUATS. First is you type their website, www.duats.com via internet. And the second one is with a DUATS provider with modem and communications program. The En route Flight Advisory Service, or EFAS. It is also known as the Flight Watch. It provides timely en route weather information upon request, and it offers weather advisories to a pilot customized to flight form, direction, and cruising altitude. Hazardous In-Flight Weather Advisory, or HIWAS. HIWAS is a national program for continuously transmitting hazardous weather information through selected navigation aids, or nav aids. Nav aids with HIWAS capability are displayed in section charts with a H in the upper right corner of the identifier box. Transcribed Weather Broadcast, or TWEB. TWEB is installed in Alaska that records meteorological and aeronautical data on tapes and continually transmits omnidirectional radio range navigation installations. So, in summary, there are different service outlets, but they all have the same purpose, which is to provide pilots with weather information should they need it. So, weather briefing. Pilots should collect all of the details essential to the operations of the flight before each takeoff. This involves a thorough weather briefing received from an FSS, AFSS, or NWS specialist. Weather specialists need to know which briefing style is required. Briefing styles are standard, abbreviated, and Outlook. So, among the three types of briefings, standard is the most detailed report of the weather. It includes the following in sequential order. Adverse conditions. This involves information on adverse conditions that can impact a decision to cancel or change flight route. These include extreme weather events such as thunderstorms, aircraft icing, or other essential things such as airport closures. Unrecommended VFR flight. If the weather for the flight route is below VFR minimum, or if it is unlikely that the flight could be made under VFR conditions due to the weather forecast, then the briefer might state that the VFR is not recommended. Synopsis. Synopsis is the description of the greater image of the weather. It provides fronts and major weather systems which affect the general area. Current weather conditions is the section that covers the latest floors, visibility, winds, and temperatures. Present requirements are not included in the briefing if the departure time is more than 2 hours away. En route forecast. A review of the weather forecast for the planned flight path. Destination forecast. A summary of the expected weather for the destination airport at the ETA, or the estimated time of arrival. Winds and temperatures aloft is the report of the winds at specific altitudes for the route of flight. The temperature information is provided only on request. Notices to airmen, or NOTAM, is the information related to the flight route that was not included in the NOTAM report. ATC delays. It is an advisory of any known ATC delays that may affect the flight. Other information is at the end of the standard briefing in which the FSS specialist provides the radio frequencies needed to open a flight plan and to contact FS. The next type of briefing is the abbreviated briefing. It is the condensed version of a regular briefing, and it is usually for updating previous information. Outlook briefing. When a scheduled departure is 6 hours or more away, an Outlook briefing should be needed. This type of briefing is a good source of knowledge on flight planning, which can affect flight route, altitude, and eventually go or no-go decisions. Aviation weather reports. Aviation weather reports are intended to provide realistic representation of current weather conditions. Typical reports include METARs, PREPs, and weather forecasts on radar. Aviation Routine Weather Report, or METAR. METAR is the observation of current surface weather reported in standard international format. METAR codes vary slightly for each country. It is given hourly unless drastic changes in temperature are present. The METAR contains the following in sequential order. The first is the type of report, which can either be METAR or equal to routine report, or SPECI, which means a special report to update the METAR. The second is the station identifier. It consists of a 4-letter code. The first letter is the country designation, and the following 3 letters is the airport identification. The third is the date and time of report, or the date and time of the METAR. It consists of 6 digits, the first 2 digits being the date, and the following 4 digits is the METAR time, or the UTC, and then followed by a Z for Zulu time. So the fourth one is the modifier. It will appear as auto if it comes from an automatic source, and it would have a COR as its suffix if it denotes revision. AO1 and AO2 is the precipitation sensor type. The fifth one is the wind. It consists of 5 to 6 digits. The first 3 digits is the direction of true wind. And the last 2 digits, 3, if knots are greater than 99, is the knots. The sixth is visibility. The prevailing visibility is reported in statute miles as denoted by the letters S and M. The sixth is visibility. The prevailing visibility is reported in statute miles as denoted by the letters S and M. It is measured in miles and fractions of kilometers. Runway visual range is often recorded following the prevailing visibility. RVR is the distance which a pilot can see in a moving aircraft down the runway. As RVR is mentioned, it is shown with an R, then the number of the runway, followed by a slant, then the visual range in feet. The 7 is weather. Weather can be broken down into 2 different categories, qualifiers and weather phenomenon. First, the strength qualifier, proximity, and weather descriptor will be provided. The strength qualifier can be low, moderate, or strong. Proximity is just a result of weather conditions in the vicinity of the airport. The notation VC means that there is a particular weather phenomenon within 5 to 10 miles of the airport. Descriptors are used to define precipitation and obscuration of some forms. Phenomena of weather can be identified as precipitation, obscuration, and other phenomena such as squalls or funnel clouds. You may refer to the figure below for the descriptors and weather phenomena that is used in a METAR. Sky condition is reported in the sequence of amount, height, and type, or vertical visibility. The heights of cloud bases are recorded in hundreds of feet above ground level, with the 3-digit number. The types of clouds are identified with their height, usually towering cumulus, TCU, or cumulonimbus, CB clouds. The figure below shows the reportable contractions for sky condition. The ninth is temperature. It consists of the air and dew point, which is given in degrees Celsius. M is denoted for temperatures below 0 degrees Celsius. The 10th is altimeter setting. Altimeter setting is reported as inches of mercury in 4 digits. The letter A often precedes it. Rising or dropping pressure can also be denoted as press RR or press FR in the remark section respectively. The 11th is Zulu time, which is a term used in aviation for UTC, which places the entire world on one time standard. And lastly, the remarks. The remarks section always begins with RMK. The figure down here is an example of a METAR and how it will look like. Next is the pilot weather reports or PREPs. Useful knowledge that cannot be obtained by any other source. It must be filed in sequence as shown in the figure. The next is radar weather reports or RAREP. Precipitation and thunderstorm regions are regularly detected by radar. Radar weather forecasts, RAREPs, or storm detections, SDs, are provided by radar stations 35 minutes after the hour. So a typical RAREP will include these information, and it will look like something similar of a METAR. Aviation forecasts. Aviation forecasts are observed observations of weather used to formulate forecasts for the same region. A variety of different predictive products are developed and designed for use in pre-flight planning. Pilots' written forecasts are the Terminal Aerodrome Forecast, TAF, Aviation Area Forecast, FA, in-flight weather advisories, SIGMET and AirMet, and aloft wind and temperature forecast, or FD. The first aviation forecast is the Terminal Aerodrome Forecasts, or TAF. A TAF is a report developed around an airport for the 5 statute mile radius. Usually, TAF reports are issued for larger airports. TAF is valid for a duration of 30 hours and is updated 4 hours a day at these following Zulu times. The TAF uses descriptors and abbreviations similar to those used in the METAR article. In sequential order, the TAF contains the following information. First is the type of report. Second is the ICAO station identifier. Third is the date and time of origin. Fourth is valid period, time, and date. Fifth is forecast wind. Sixth is forecast visibility. Seventh is forecast significant weather. Eighth is the forecast sky condition. Ninth is the forecast change group. And the 10th is the probability forecast. This is an example of a terminal aerodrome forecast. It looks somewhat similar to a METAR,